My dear, in today's class, I'm going to solve, I'm going to discuss JEE Advanced Illustration, chapters electrostatics. So I'll take any random question for entire electrostatics, right? So stay in the meeting, stay everyone lives students. So this is first question. Yes, beta. So we'll go through this everyone. Okay, have a look. Just wait, student, at least 1 minute here. Yes, at least 1 minute. Meanwhile, I'm going to write the questions. Right. Okay. So, student, this is the first question I can say for this class. So, what question is student? It's a very common standard questions. You can say like that. So, beta, this is questions. Electric field students, you can take like that. Not 1 minus small r upon capital R. Very small r, what you can say? It's a distance from the center of a circle. Right. Here is to find electric flux to the plane of the circle within it. Find electric flux. Right. Electric flux passing through the plane of a circle. Plane of circle within it. Right, my dear? Okay. So this I can say data beta means in the questions you can take like it. You can say this is students circle. In fact, mention the question beta. Uh, Now students, you can take consideration. This is electric field lines coming like this. So you can say this is what? Direction of electric field line. What might be direction of electric field line? What we wish to find? Find electric flux passing through the plane of a circle within it. So electric field is not constant here. Electric field is what, my dear? It's a variable. What you can say electric field is variable. Okay. So students, this circle you can treat as a disk. You have to treat as a disk, right? If this is disk, yes, I hope all of you remember. Disk is a what form of ring. Disk is a what form of ring, right, my dear? So if this is, if you are just considering this circle as a disk, so what is the first step for this question, students? I hope all of you remember. Now you have to first move. You have to first move x and take element dx. I hope all of you already remember this step because now just I'm applying this concept already. You did, I can say, rotation and center of mass as well, right? Jai Shri Ram, student. So this is student first step for this question. We have to move x and take element dx. You have to move x and take element dx as a ring, as a ring. Okay. So we wish to find beta electric flux. We wish to find what? Electric flux. Right. So we have to move x, and this is that's our student. This beta this distance what you can say elemental ring, which is what? Dx. Area vector always perpendicular to what? I hope remember for open surfaces. So this is what, my dear? This is what? Direction of area vector. This is what that, because we are doing operation for this elemental ring, this elemental ring. So this is what you can say area, directions of area vector. So now I'm calling it's dA because it's small area. We are doing only operation for this elemental ring, right? So area beta, if you remember, I said in the this thing in classroom, student, if you have a ring, this is the ring. You can take as a constitution. What, my dear? This is what ring, right? Okay. So this is the ring which you can take as a consideration. If this is the ring, student, now you can just apply force here. So what you can say, the ring becomes rectangle. Ring becomes what? Rectangle, right, my dear? Same thing here, bacha, here also. As I say, you have to move x and take element dx as an elemental ring. So if this is ring beta, so what you can say, this ring, my dear, this ring beta, you can just, you will apply the force, so ring becomes a rectangle. What, my dear? Ring become rectangle. So we have to write what's the length of rectangle and what's the width of rectangle, right? So length beta, how much you can see? This is circumference of circle beta. So this is, you can write, my dear, this is 2 pi r. And what's beta? Means r, I mean to say x, 2 pi x. And this is width of the, you can say, ring. This is what? Dx. This is what dx. So simply here, here you can write what's the value of dA vector. So elemental area you can write, my dear. This is what? Length into breadth here. So you can say 2 pi x into dx. What, my dear? This is expression which you wrote area for, I can say, this elemental ring. Area for what, my dear? Elemental ring here. D is equals to 2 pi x dx. We wish to find basically flux. We wish to find what is it? Flux here. So now bit of flux passing through what? It is a elemental ring. Students, you can write flux, that is what? D phi. Because we are doing operation for a small element. So this is what, my dear? D phi here. So D phi, what you can write? This is E into dA. E vector into what vector we can say? dA vector here. Okay. So this is beta what? You can write D phi. As usual, with party. Electric field mention, my dear, in this question as well. So you can use this expression of electric field. This is what, my dear? You can say E naught. 1 minus. What was that party? This R here, you can just reverse as X only. This R beta, you can treat as X beta. So 1 minus, you can say, this is small r, 1 minus x upon r into d beta we already found. Just you can put over there. 2 pi x into dx. Just beta, open the bracket here. So you can write d phi, which is equals to beta E naught 2 pi x dx minus beta g. What you can see? E naught into x by r into beta 2 pi x into dx. Now, I can ask, what is the limit you can apply? What is the limit you can apply? That is what? What's the radius of the ring here? That is capital R, Mr. So you can apply to limit, just integrate both sides. So integrate both sides here. So what's the limit, Mr. G? My dear student, limit you can write 0 to capital R. 0 to capital R, Mr. So d phi beta becomes 5 only. D phi, what you can write, my dear? 5 only. Right. So this is, you can say beta E naught. What is student? This is 2 pi. And x is, you can write beta x square by 2. Just apply the limit beta g in next step, not now. Minus student. You can see this is what? E naught into beta, this is 2 pi x here. So you can write 2 pi x cube by 3. Limit beta remains same, my dear. 0 to r. Okay, further beta, this is the last step for this question, students. You can write. So this is what? My dear flux. Phi. Phi you can write here. This two beta cancel. So you can write, my dear, E naught into pi into r square. E naught into pi into beta, what you can see? This is what? R square. Okay. Minus beta z. What you can write over here? E naught to pi r cube by 3. Now, further student, this to calculate here. What you can say? This is what 3 goes this side. 3 minus 1, 2. So finally, bachcha party, what you can write here for this question? Everything is fine, beta? Yes, yes, perfect, perfect. Okay, beta, do one thing here. That is more better for us. What might here? You can say for further calculation, you can take E naught to pi common. So here what we can write x square by 2 means r square by 2. Just I'll do better further there for more clarification. Easy solution better party. So you can see my dear, this is the flux here. Student, here I'm considering just I'm keeping it out to pi E naught. What with a x square by 2 minus beta g. What you can say x cube by 3. 0 to r. Just do it further here. Just simplification. Student just put the limit. So now should in it will if once you will put the limit. So what you can say 2 pi epsilon naught r square by 2 minus this is what my dear r cube by 3. 2 3 just beta. So you can say this is what phi is equals to 2 pi epsilon naught. 2 3 the 6 here. So you can say beta for this condition. You can say beta for this condition. Okay, you know what I missed. That is R is here also. Yes, one R is here also. This is R square basically. So you can say this is 3R square minus beta. You can say 2R square. Right now. So 3 minus beta. R square only R you can write. So flux what my dear? 2 pi epsilon naught. This is you can say R square by 6. 2 3 is 6 beta. So flux finally you could write pi epsilon naught r square by 3. Pi epsilon r square by 3. So it's a good question, student. Yes, beta. It's a good question, my dear. Okay. But have a look at next question, my dear. Yes. So these kind of questions, little bit good only. Just practice required more. Now, beta, the next question. What's my dear next question here? You can take it in consideration like uh, you can take a ring of radius. In a ring of radius, you can take my dear. This is 0.1 meter. What you can say this is what? 0.1 meter. Right. Okay. Next beta party, you can say, yes, beta. Literally, which I solved this question, my dear. Yes, this question, it's good question, beta. It's good question here. So beta, the ring of radius beta, what mentioned? This is 0.1 meter. Is made of what? You can say thin metallic wire of area cross section, beta. Let us suppose area cross section you can take. So this is 10 to the power minus 6 meter square. Yes, yes, good, good. Correct, question. Area beta I can take care. Area of the ring. Right. The ring is uniformly charged. You can say which this is I can say diagram here. I can make diagram. I don't have much time here. Let's go through that. You can see this is the we have a ring. We have a ring, right? Ring I can see this is what a bit everywhere. Uniformly charged. Charge you can take beta on the periphery of ring. It's nothing but it's beta plus pi coulomb. What student? You can say plus pi coulomb. Right. Okay, that is charge. Now beta just find the change in radius. You have to find delta r. You have to find delta r. So if we placed one charge at the center of a one charge, what you can say, at a 10 to the power minus 8 coulomb. Please at what center? This R is known for us here already. This is point 1 meter. Yes, beta. Young's modulus you can take beta. For this question, Young's modulus, this is 2 into 10 to the power 11 Newton per meter square. What my dear? 2 into 10 to the power 11 meter per square. Okay, we wish to find delta R here. If you remember this question beta, as I taught here, this question in classroom, and literally it's a very good question and very standard question. That is the first point for the question, student. But I have a look here. Uh, Here I'm not going to derive entire result. I'll use result directly, bacha. But if you remember the questions here, that is, I can say to find excess tension due to these questions here. If you remember, there is a ring which is what uniformly charged, and beta there is a transmitter. If I place extra charge, so what is excess tension in the ring? Right. So here I suggested here for to each and every student. But for getting tension here, for this three, what you can apply? Simple chapati. FC upon 2 pi. FC upon 2 pi. And FC is what? Beta, who is playing role of FC over here? That is what? Electrostatic force. That is beta what you can see? Electrostatic force here. So tension beta you can write here. FC. FC is what? Nothing but K Q1 Q2 by R square. Simple beta G. So you can write beta K Q1 Q2. Beta R remains same here. R square into 2 pi. So beta I'll get here from here. Tension, my dear. So tension you can write beta K. You can use 9 into 10 to the power 9. One charge you can take beta the pi. Another charge 10 to the power minus 8 coulomb. K Q1 Q2 by R square. Means you can say zero point 0.1 into zero point 0.1 into beta 2 pi. Listen this one carefully here. Pi cancel. Right, beta? This is cancel here. 90 you can write. This is what you can say 90. What my dear? This is what 90. So which I can say for this condition at 90, which this is what 0.1 here. So this is zero point 0.1 into zero point 0.1 into 2, bacha. So you can say, bacha, this is what basically 45, and this 2 decimal here, I can see in upper direction in numerator restaurant. So final tension you can write 4500 Newton. What my dear? Tension is equals to 4500 Newton. It's a tension here. It's a tension. Here, what we wish to find, student? What we have a target to find here? Delta R. We wish to find what, my dear? Delta R. If we wish to find delta R here, then what you can apply for these questions? Bacha, Young's modulus mentioned. Student, Young's modulus already mentioned in the question. So at least you have to think once mechanics of solid concept. At least you have to think mechanics of solid concept. So what is the mechanics of solid concept, my dear? Okay, Bachaji, if you remember, for against mechanics of solids, Young's modulus is defined. Young's modulus is defined. This is stress upon strain. Stress upon what, my dear? You can say strain here. Okay. So, yes, beta. What is stress here? This is nothing but it's about you can say force per unit area, and strain beta you can write here. This is delta R by R. We used to find delta R according to I can say demand of the question. So you can write Bachaji. Delta is what you can say F into R upon Young's modulus into A. This is delta R with party F into R upon Young's modulus into A. Now beta force is nothing here. It's what you can see tension force, which we already found. So you can write my dear delta R here. This is 4500. Radius beta mention the questions here. How much? This is 0.1. Young's modulus beta also mentioned in this question, students. 2 into 10 to the power 11 into beta Young's area here. Area what you can see? This is what 10 to the power minus 6. 10 to the power minus 6. Okay. Just do beta further calculation here. Delta, what you can write with party? Uh, this is what? Beta 4, 5 into beta plus 2. You can say 10 to the power 8 beta, 6 plus 2 minus 11 by 2. Right now, it's party? Okay. So what you will get with party? Delta beta 22.5 into beta 10 to the power minus 3 in meter. In meter, what you can see? Meter, right now. Okay, so delta R you can write finally here. That is, bachcha ji, correct na? 22.5. This is point 1. Okay, this is point 1. One more. So it's not 2.25. It's 2.25. Right. So beta you can write finally 2.25 10 to the power minus 3 meter. Or you can write my dear 2.25 mm. You can write what? 2.25 mm. So this is, I can say, the question. But basically electrostatics, that was applicable only. Electrostatics, in this, I can say entire numerical solutions, I used F is equals to K Q1 Q2 R square, remaining 11th class concept. So it's highly required if you are literally, if you wanted very good knowledge in 12th class physics. So you have to must should be crystal clear in 11th class concept. Then you will enjoy. Then you will enjoy, my dear. It's a hardcore truth. Okay, fine with Sabati. Sabali, look question, next question, sir. Okay, so again, your questions, as I said, I'll take random questions. I can see on electrostatics. So this is, I can see with one more next question, or you can say this is question number third for today class. So what's question, student? Student, I have two long wire. I have two long wire, right? So you can take with this is the wire lambda one. This is the wire lambda one. But directions of this wire in what you can see in outward directions. What, my dear, in outward directions? Okay. In front of this wire, student, there is one more another wire. As I said, there are two long wire, right? Strategy for this wire. This is, my dear, uniformly charged. This is what, my dear, uniformly charged. Let us suppose charge density on this long wire is what? Lambda 2. Student, this is mentioned in this question as well. You can take separation between these two wires. Separation between these two wires. Better what? You can take A. You can take what, my dear? A. Right? Okay. Basically, bacha, what we wish to find here? Find a force of interaction between the rods. Means you can see we have two charge rod. One has a charge lambda one, another charge what? Lambda two. So we have to find interaction force between the rod. What, student? Find interaction force between the rods. Yes, beta. This is the question here. We wish to find what? Interaction force between the rods. Okay. Then, bacha, you can say, sir, this is what? In outward direction. This is what I can say rolling of outward directions. So if you remember beta basics property, how to find electric field for a rod and all, for infinite rod, semi-infinite rod. So I'm going to apply beta same concept. So here student, I'll move. Student, here I'll move beta from this point here. I'll move Y. I'll move Y. Right. And I'll take element dy. I'll take limit d by. Student, here we wish to find what is the interaction force in between these two. So you know, beta, these two are what? Like charges. These two are what? Like charges. So they will repel each other. So beta ji, for this condition, you can just make diagram. This is what you can write, my dear. It's a DF force. You can write, my dear, this is what DF force. Let us suppose, students, I'm considering this angle is theta. So you could easily say, this is remains theta. This is remains theta, right? Now, what's about more points here, which you can take in consideration? Beta, force belongs to quantity vector. Force belongs to quantity vector. If force belongs to quantity vector, so you must take component. So you must take component here. So what you can see, df cos theta, df sin theta. So here you can write, my dear, this component of df. This is, students, you can write df cos theta. This is what, my dear? This is df sin theta. This is df cos theta. This is what you can say, df sin theta. Now, bacha, okay. So, beta, here you can say, what a force on a rod we have to find. So, bacha, because this is what df element. So, now, students, I'm going to use formula. This you can say general formula of electric field. So, which I have done better. That is step one for the question. Step two, just moving ahead for this question solution part. Right, my dear? Okay. So here I'm going to use here because first I'll write expression of electric force, electrostatic force due to small elemental which I have taken a rod and discharge vector. So first I'll write which is small expression of force. This is df. This is df. What was it? I hope you remember here. dq into E1. E1 due to this one. dq into E1. I hope it all of you remember here. Electric field due to infinite charge wire. So what beta? This is 2k lambda by r. Right. So k beta, I'm going to just beta just replace here. This is 2 lambda and k beta 4 pi epsilon into area. This cancel. So now further I'll use in these questions electric field due to a long rod or you can see uniformly charged wire. This is what, my dear, lambda upon 2 pi epsilon into r. Electric fluid are what you can say lambda upon 2 pi epsilon naught into r. Lambda upon 2 pi epsilon naught into r. Right, my dear? This is what you can say df. df is what? dq into E1 here. Okay. So, bacha ji, if you wanted to write electric field of E1 at this element, so what you can say, bacha? This is r here. This is r. And r is what? You can say a square plus by a square. R is what, my dear? A square plus by a square. It's a good question, bacha. Just listen carefully here. So this is, my dear, df is equals to dq. What about dq, beta? Just write once, beta. This is dq over here. So I hope you can write here simply over here dq. What is lambda here? Lambda you can write charge per unit length was that. So charge what we can write? dq is equals to beta z lambda 2 into dy. dq beta, what you can say, this is lambda 2 into dy, lambda 2 into dy, right, whichever way. So this is the df force here. This is what beta I can say, df force. So dq beta already already have written, the students. So this is what lambda 2 into dy, even here. So even beta, what you can write over here, this is lambda 1 upon beta z, this is 2 pi epsilon naught, 2 pi epsilon naught. And this is R, bacha. Already I said here. So this is what, my dear, you can say a square plus by a square. This is from Pythagoras I can write. From Pythagoras beta I can write here easily. Okay. So this is the term set which you can keep in your mind. So this is what expression of df. Expression of df student. I'm going to rewrite again here. So this is, you can say lambda 1, lambda 2 dy 2 pi epsilon. This is what I can see expression for this one. But we used to find what is the F total interaction force between this you can say lambda 1 long beta what you can say long straight conductor beta and beta lambda 2 here. So beta for this one here, what's the force you can say df cos down the df sin theta what cancel each other. Df sin theta what you can say cancel each other here. So total force on the rod 2 is. So beta you can write here F net. So F beta what you can write just integration student I can say step 3 here. So this is you can write over here df cos theta. What my dear? df cos theta. df theta we already found here. So what's the limit of theta here? What is the limit of theta? You can see in Bacha party. So this is what minus infinity. This is what plus infinity here. So beta just be careful Bacha party everyone. Lambda 1, lambda 2. This is dy beta 2 pi epsilon naught. This is a square plus y square. And what about cos theta here? What about cos theta with party? Tell me, what is the value of cos theta from this triangle? What? Tell me, anyone from all of you. So simple, we can write here. This is what? Base upon hypotenuse. So we can write, my dear, cos theta is equals to a upon root of a square plus y square. I hope you're getting my point. Right, my dear? So just this way looking right over here. So a upon beta c root of a square plus y square. A square plus y square. Okay. Just here. Just you can multiply this one. It will just multiply this one here. So what you can say a square plus y square. So finally, I can write here expression of force and limit beta I can apply minus infinity to plus infinity. So finally, students, you can say f is equals to lambda 1, lambda 2, 2 pi epsilon naught into a integration of d by upon beta what? You can say a square by a square. A square by a square beta. Limit what you can apply? Again here, minus infinity to plus infinity. Minus infinity to plus infinity. I hope here all of you remember this, I can say formula. Integration of dx upon a square plus x square. This is what, my dear? 1 upon a tan inverse x upon a. 1 upon a beta. What you can say tan inverse x upon a. Right. So f beta you can write finally here. Lambda 1, lambda 2 into a. Upon beta this is what? 2 pi epsilon naught here. So this is beta you can say 1 upon a. This is tan inverse by upon a minus infinity to plus infinity. Beta what you can say minus infinity to plus infinity here. So you can see beta. This a beta cancel each other. This a and this a beta cancel each other here. Force you can write beta. Lambda 1, lambda 2, 2 pi epsilon naught. Upper limit here. So you can say this is what? Tan infinity here. This is what? Minus. But I can say minus infinity here. I hope you remember here. In the classroom, my dear, I said vomiting concept. So this is what vomiting. What is the meaning of vomiting concept? Means you can say like you can say something like that. So this will come outside here. So minus minus get plus. So tan 90, you can say what beta? It's a tan infinite. What we can say 90 degree. So finally, you can write, my dear, lambda 1, lambda 2, 2 pi epsilon naught. What was the party? This is pi by 2 minus minus plus here pi by 2. So this is what you can say, bacha remains pi. This is what, my dear, you can say remains pi. And pi beta we have. So you can say f is equals to lambda 1, lambda 2 pi upon 2 pi epsilon naught. Pi cancel here. So you can say lambda 1, lambda 2 upon beta g 2 epsilon naught. lambda 1, lambda 2, what, my dear? You can say basically this is the 2 epsilon net. This is what, my dear? 2 epsilon net. Okay, fine. Just better next question, sir. Yes. Beta, you can take, you have a charged charge beta. What you can see? I can say hemispherical cup. This is my idea. You can take arrangement like this. This is, you can see, you have I can say hemispherical cup, right? There is a kind of arrangement, students, mm, which you can take. That is, there is one dipole. Yes, beta. What you can say, there is what? One dipole, right? So dipole beta arranged like that. You can say an electric field. Both are in same directions. You can say bacha electric field and P. Electric field and beta what? Dipole moment. Both are beta what you can say. I like beta in same directions here. Uh, I hope you remember everyone here hollow sphere. What we can take? It's a hollow hemisphere. So you are pretty confident as I thought. Sigma Coulomb per meter square. Sigma Coulomb per meter square. Okay, find the period of oscillations. Find beta J. Find time period of find time period of oscillation. Time period of small oscillation beta, not very huge here. What beta we wish to find? Find time period of what beta? You can see small oscillation there. Okay. Due to beta, I can say this thing already uh, I said in the classroom. Electric field due to what? Hollow hemisphere. This is what, my dear? It's a half of what you can say. It's a half of, you can say, electric field due to infinite seat, right? So here, beta, I can see this is first place for the questions, my dear. Electric field you have to must write. This is what sigma upon 4 epsilon net. You must remember this is there, highly required. I repeated multiple times in the classroom. So E beta what? Sigma by 4 epsilon at, right? Which if anywhere, na, if you wish to find time period, so from your side, you have to take in consideration, you have to avail little small displacement because they mentioned you have to find time period for what? Time period for small oscillation. Time period for what beta? We can see small oscillations here. So this is my idea. I can see step one for these questions. Now, yeah, I can see student. This is step two. I'm going to write. I hope all of you remember, yeah, relation what? I can say torque, moment of inertia, and electric field. So torque beta, what you can see, this is uh, P E P E sin theta. Torque beta, what you can see, P E sin theta. Here they mention small oscillation. What made it small oscillation? So this, I guess, this is the part of theory here. I hope you complete it definitely. So you can write, my dear, torque is equals to, if theta is small here, so what you can say, theta is small, so you can write freely, sine theta goes to theta, right, beta? So this is, you can say basically PE into theta. This is what, my dear, you can say PE into theta, right? Okay, this is a torque here. I can say, bacha, restoring angular acceleration of a dipole beta. Right, which has E, the restoring angular acceleration of a dipole. Because this is the force beta. This is who's only responsible to avail, I can say, oscillation. So restoring acceleration, in fact, you can say angular acceleration. Restoring angular acceleration of dipole. I hope all of you remember here. Alpha is equals to minus tau by I. Alpha is what, my dear? You can say tau by I, right? Okay. Beta, I can say torque. Basically, yeah, you can use the beta this near. Torque is equals to I alpha. So alpha is what? Alpha beta, I can say torque upon I only, right? Okay. So, bacha party for this condition here, you can say what is torque? What you can say? This is what? This is here. PE. What you can say, bacha? Torque is what, bacha party? I alpha here. So alpha is what? Torque upon I, bacha party. So alpha I can write minus P theta beta minus PE theta upon I only. PE theta upon beta, what you can say? This is what remains I only, right? So beta for SHM in step third here. For SHM, beta alpha angular SHM here. I hope you remember. Otherwise, I'm writing omega square into theta. Alpha beta, what you can see? Minus omega square into theta. So, bacha ji, omega here, what we can write? Because beta, this is alpha here. This is again alpha. So, do one thing, bacha. Let us suppose this equation number A, this equation number B. Just equate these two. Just equate these two, bacha party. Right. So, I'll do beta. I can show next paper. Yes, bacha. So, what you can say? Alpha is equals to minus PE theta upon I. And alpha is what? Minus omega square theta minus bacha PE into theta upon I. So you can see this minus finish. And beta, we wish to find omega here. So omega beta, what we can see? This finish here. So omega, you can write root of PE upon I. Omega beta, what you can say? Root of PE by I. Right. So, but electric field, we know already. I hope all of you remember. Electric field to semi, I can say it as spherical body here or hemisphere. This is sigma by 4 epsilon naught. So you can write omega is what, which this is P and sigma by 4 epsilon naught into I. 4 epsilon into what, beta? You can say I. So this is what will get omega. This is what, my dear. Finally, you got value of omega. If you once you got omega here, so we can easily find time period of oscillation. You can say which this is shape number 4. So this is time period of oscillation. Time period of what you can say oscillation here. So T is equals to 2 pi by omega. Omega beta we already found here. So this is 2 pi which root of P into sigma into beta. This is 4 epsilon naught I. 4 epsilon naught I bacha party. So this is, my dear, I can say answer of this question. This is what, my dear, I can say answer of this question here. So these other question I can say literally not tough at all, but I can say that it's required here because everywhere I applied only 11th class concept. That's why I see that I can say beginning of today class. You have to in- enough confidence on 12th, 11th class. Then you will grow. Then your knowledge will grow in, I can see, chapter of 12th class. Otherwise, it's very tough. Otherwise, it's very tough to recall. Okay. So now, let's say this is all about today class here.